we have a quadratic expression, right? So it has a x squared as the highest power of x, and we have this unknown constant k that appears twice. And we want to find the values for k. So it could just be one value, it could be multiple values, or a range of values. So that if we were to graph this, let's say, it would always be above the x-axis, right? It always has a value greater than 0, regardless of what we put in for x. Right, so graphically, we have our x-axis. Let's say that this is equal to y. For it to always be greater than 0, regardless of the input x, it's saying that it stays in the top half of our xy plane, right, above the x-axis. So for a quadratic, that could look like this. Could it look like this? Could it be a negative quadratic? No, it can't, right? Because even though for some parts it's greater than 0, it'll eventually go below the x-axis. What about one that looks like this? It doesn't cross the x-axis, that's true, but it's not greater than 0, it's actually less than 0. But we'll come to that case in a moment. Okay, so we have a quadratic, kx squared minus 12x plus 5k. And just visually from this example, the sketch I've drawn, we want there not to be any roots, right? Because if there was a root or a solution, it means that there's either one intercept or there's two. And in both of those cases, it means that it's not always greater than 0. So we could say the discriminant must be less than 0 or no real roots, right? And just again, visually, we know that there can't be any roots for this problem for it to be greater than 0. So the discriminant, if you recall, is b squared minus 4ac. So where b is the term in front of x, a is the term in front of x squared, and c is the constant. So just substituting in from our expression, we get negative 12 brackets squared minus 4 times a, which is k, times c, which is 5k. Simplifying that, 144, that is minus 20k squared. Now solving, well, that's our discriminant, right? Full stop. Now, for there to be no real roots, the discriminant must be less than 0. Right, so now I'm putting it into an inequality. So we'll add 20k squared on both sides, divide both sides by 20. So k squared must be greater than 144 divided by 20. So when we get here, you might be thinking, all right, I'll just square root both sides. Not so fast. Inequalities works a little bit differently. I'll show you two methods. So we can square root both sides, right? But this is just to get the key values. So I'll just write the key values are the square root of 144 over 20 and negative of that, right? Because when you square root, you get a positive and a negative solution. Just as decimals, this is about 2.68 and negative 2.68. Okay, so now just looking at this graphically, just this standard parabola. Goes like Actually, scratch that. Let's stick to this method first. So again, just to recap, we put the discriminant into an inequality. We said it's less than 0. We've rearranged for k squared. We took the square root of both sides to find key values of 2.68 and negative 2.68. So on a timeline, just a number line, not a timeline, excuse me, we'll have negative 2.68, positive 2.68. We want to pick a number in between those two values. Smack in the middle could be 0. And if k was equal to 0, would this inequality be true? So if we substitute in 0 for k, we would have 144 divided by 20 is less than 0 squared. Now, is that true? No, a positive number is not less than 0. And that tells us that k cannot be between these two values, and in fact must be everything outside of those two values. So instead of between negative 2.68 and positive 2.68, it is outside of. So let's just check that. So if k was 5, is 5 squared greater than 144 over 20? Well, yes, right? 5 squared is 25, which is greater than 2.68. So therefore, k must be greater than 2.68, and k must be less than minus 2.68 for no real roots. Awesome. But now back to the problem. It's not no real roots, it's that it must be greater than 0. So to be greater than 0, we said it needs to be a positive parabola, right? Because if it's negative, even if it's negative and it has no real roots, like this bottom one here, it's not greater than 0. So in order to have a positive parabola, the coefficient of x squared, in this case k, must be positive. So k must be positive for positive quadratic. Therefore, k must be greater than 2.68. Right? It lets us eliminate these negative values for k. Great. And so just again to check, once you've got that far, just double check. So if you put in a number above 2.68, say 3 in for k, so we'd get 3x squared minus 12x plus 15. If we were correct, this quadratic will always be positive, no matter what value of x you give it. And you can just check that by graphing it or substituting in some values. Great, so one final recap of this problem. We had a quadratic expression. We found the discriminant, b squared minus 4ac. We set that to be less than 0 to have no real roots, so that it's not touching the x-axis. But that could also mean negative quadratic, which isn't what we want. So we then reasoned that the coefficient of x squared, which was k, must be positive. Therefore, k must be greater than 2.68.